Question number 10, a uniform flat circular rim. This is a uniform flat circular rim is balanced on a sharp vertical nail by supporting it at point A. There's a nail and exactly at point A it's balanced, okay? Mark the position of the center of gravity of the rim in the diagram by letter G. So I draw the diagram once again. You can see here, it's balanced. It's as good as suspended at point A. And whenever an object is suspended, okay, always remember the center of gravity lies just below the point of suspension. So below the point of suspension at the center of the rim, okay, geometrical center of the rim, it is below the point of suspension. That point I mark it as G. Okay, that point I mark it as G. Okay, you have to only redraw the diagram and mark it. Okay, now question number 11. Question number 11, the figure below shows 3 pieces of cardboard of uniform thickness cut into 3 different shapes, okay? On each diagram, draw 2 lines to indicate the position of center of gravity. The first one, you can see it's rectangular in shape. When it is rectangular in shape, you know, in rectangle, the point of intersection of the diagonals gives the center of gravity. So what I do, I just draw the 2 diagonals, okay? I have to draw 2 lines and the point of intersection has a center of gravity. So what I do, I just draw 2 diagonals, okay? One diagonal and the second diagonal, okay? And where these diagonals intersect, that is your point of center of gravity, okay? In the same way, for a triangle, you know, for a triangle, the point of intersection of the medians. So what I do, I draw any 2 medians. Now, what are medians? Medians are the segment joining the midpoint of the side and the opposite vertex. Suppose this is the midpoint of the side. So the segment joining the midpoint of the side and the opposite vertex is a median. So this is a median. A segment joining the midpoint of the side and the opposite vertex is a median. So wherever the 2 medians intersect, beta, that is your center of gravity. That is your center of gravity. Okay. Now, in case of circles, they want me to draw the 2 lines. Okay. But actually, what happens in a circle? In a circle, the center of the circle is what you can say, the center of the circle is the axis of symmetry. The center of the circle is the axis of symmetry. Okay, but on each diagram, 2 lines indicate the position of, draw 2 lines to indicate the position of center of gravity. So what I do, I draw any 2 diameters, you know, the 2 diameters where they intersect gives the center of gravity. Okay, children? Okay. Now, with this exercise gets over. Okay, we go to the next. Explain the meaning of exercise 1C, question number 1. Explain the meaning of uniform circular motion, giving one example of such motion. Okay, answer: when a body moves along a circular path, with a uniform speed, then the motion of the body, the body is said to be uniform circular motion. So remember, it's so simple. When a body moves along a circular path, uniform speed, and the motion of the body is said to be uniform circular motion. Now, they want me to give one example of such motion. Example: the moon revolves round the earth in a circular path, with a uniform velocity, with a uniform speed, sorry, not velocity, with a uniform speed. Hence, the motion of the moon is uniform circular motion. Uniform circular motion. Okay, children? You could adjust. Okay. Now, we go to question number 2. Question number 2. Draw a label diagram of a particle moving in a circular path with a constant speed. In your diagram, show the direction of velocity at any instant. Suppose you can see here what I do. I draw one circular path and my body is moving. I cannot, what body may be a particle. Particle can be a point, okay? My point is going like this from A. My point is going from, suppose here A, it's going from A to B, from B to C, from C to D. Got it? At a uniform speed. Particle is moving at a uniform speed. And at every point, the direction of the velocity is shown by a tangent line. Like at A, the direction of the velocity is shown by drawing a tangent at A. Direction of velocity shown by drawing a tangent at A. At B, the velocity of tangent, the direction of velocity is shown by drawing a tangent at B. And at C, the velocity, the direction of the velocity is shown by drawing a tangent at C. Got it? And at D, okay, at D, the velocity, direction of the velocity is shown by drawing a tangent at D. So you can see here, the direction of the velocity is keeping on changing. Got it? So in your diagram, show the direction of velocity. So you can see the direction of velocity at any instant, okay, at any instant, okay. Now, this is with question number 2, okay. Now we go to question number, is it possible to have an accelerated motion with a constant speed? Name such type of motion. Question number 3, is it possible to have an accelerated motion with a constant speed? Name such type of motion. So naturally, you have been studying, children. Yes, the body is having a uniform circular motion. But at every point, when I look at the direction of the velocity keeps on changing. That means the body is having a variable velocity. Any motion where there is a variable velocity is said to be accelerated motion. So naturally here, even though the body is having a uniform speed, but variable velocity because of the direction, but it is said to be an accelerated motion, because whenever variable velocity is there, it becomes an accelerated motion. So answer for that, is it possible to have an accelerated motion at a constant speed? Yes. Got it? Name such type of motion. Uniform circular motion. Uniform circular motion. I hope people understood me here. Okay, I just wrote the answer for it. Okay. Now we go to the question number. See, give an example of motion in which the speed remains uniform, but the velocity changes. So the motion of the moon around the earth is a uniform circular motion, but the direction of velocity at any point in the path is shown by a tangent line at that point. Okay, at that point. Hence, the direction of velocity keeps changing. Now I go to question number 5. See, a uniform circular motion is an accelerated motion. Explain it. So this is the first part of the question. Okay, a uniform circular motion is an accelerated motion. What sort of questions is made? Like first at a time, one at a time. So the first part, you see, for a body having uniform circular motion, the magnitude of velocity is constant, but its direction keeps changing. Hence, the velocity of the body is variable. Any body with variable velocity is said to be an accelerated motion. Hence, uniform circular motion is an accelerated motion. Now, what is the second part of the question? State whether the acceleration is uniform or variable. Now, as the direction of the velocity is changing, the direction of acceleration is also changing. Hence, the acceleration is a variable acceleration. Okay, since the direction of the acceleration is keeping on changing, got it? The acceleration is a variable acceleration. So I'll just say since the direction of the acceleration is changing continuously, hence it is a variable acceleration. Hence it is a variable acceleration. What is the direction of the force at any instant? Okay, the direction of the force at any instant. Name the force at the name of the force. Sorry, the force that causes this acceleration is called a centripetal force. Is called a centripetal force. Is called a centripetal force. What is the direction of force at any instant? The force that causes the acceleration is called centripetal force. Okay. Now, what is the direction of force at any instant? The direction of the force at any instant is towards the center of the circular path. Towards the center of the circular path. Got to draw a diagram in support. So the diagram is given. Okay. Now, anyhow, I just sent this answer. Got it, children? Now we go to the next question. Question number 6. It says differentiate between uniform linear motion and uniform circular motion. So uniform linear motion, in this motion, I'll say in this motion, 1, okay? In this motion, the speed is uniform, speed and velocity are uniform. Okay, whereas here what will happen? In this motion, that means a uniform circular motion. In this motion, the speed is uniform, but the velocity is variable. Second one. Now, this uniform circular motion is not an accelerated motion. It is not an accelerated motion. It is not an accelerated motion. Whereas Icse, it is an accelerated motion. It is an accelerated motion. It is an accelerated motion. Okay. This question number 6. Question number 7. Okay. State the name the force required for name the force required in circular motion. Name the force required in circular motion. State its direction. State its direction. State its direction. So what is the answer, beta? Answer, I'll say centripetal force. What is the name? Centripetal force. Okay, centripetal force. Okay, it is always directed towards the center of the circular path. Center of circular path. What is centripetal force? The continuous change in direction of motion of a body in a circular path. Continuous change in direction of motion of a body moving in a circular path, moving in a circular path with uniform speed is due to a force of attraction. Force of attraction acting on it from the central circular path. This force is called centripetal force. The continuous change in direction of motion of a body in moving in a circular path with uniform speed is due to the force of attraction. Is due to the force of attraction. Is due to the force of attraction acting on it from the central circular path. This force is called a centripetal force. What do you Okay, children, we stop here today.